Hello, good evening, everyone. So, am I audible? Right. So, just let me know in the comment section that whether I'm audible or not. Okay, great. So, good evening, everyone. I'm Akshay Dubey, and I'm currently pursuing my master's in mathematics and computing from Birla Institute of Technology. And I am an incoming visiting master research student at Ryerson University, Toronto, Canada. And currently, I'm working with as a deep learning engineer with Aiborne.tech. Okay. So, hi guys. So, basically, I have experience with natural language processing, computer vision, machine learning, deep learning, as well as graph machine learning too. So I will share my work link after the session so you guys can connect with me over there and just let me know in case of you need any help or if you ever need some discussion regarding projects or something, so you can connect me over there. Okay. So should I start the session or wait for some 1 or 2 minutes? Just type in the comment section. So let me just know from where are you all, like from which state or from which country. So like there will be diversity from different states, right? And everyone is comfortable in English. Okay. Okay. So Bangalore, Kolkata, Maharashtra, Uttar Pradesh, UP. Great, great, great. So let's start. So basically the topics for the day one are the basics of computer vision. So basics of computer vision, we'll be covering the topics such as what is computer vision, its use cases and its examples. And then after this introduction session, we will completely moving towards enhanced experience with handling images using NumPy, as well as if we get enough time. So we will be also going through OpenCV as well. So basically, computer vision is a field which involves applications from across all the fields of science and in industry as well. As on the right, you can completely see that computer vision has its application in signal processing, physics, and mathematics is the core of computer vision. Computer vision is being used in artificial intelligence as well, and different other fields like manufacturing and gas, petroleum, coal mining, etc. So computer vision is being used in different fields. So basically, what is computer vision? So a computer vision is a subfield of artificial intelligence that enables computer to understand and gains insights from visuals such as images, videos, or and visuals can be of any type. It can be videos, images, or short videos, or there are some special type of formats produced by healthcare imaging devices. So that comes under the umbrella of computer vision too. So actually the computer vision is actually inspired from actual human vision. On the right, you can see that we humans, we as a human, if we want how our vision basically works, we look at an object using our eyes, and then the information goes to brain, and then brain decides that yeah, this is a specific type of object, or that's and what is happening in front of our eyes, our brain processes it and gives us as output. Okay, so here you can see that it's a plate which contains different types of fruits. There are orange, banana, apple, okay, peach, etc. So as a human, how we perceive images, okay, so we use our eyes to look at the images. The images goes as an input to our eyes, and then the features which are extracted by our eyes goes to brain, and then brain is able to identify easily that yes, this is a particular kind of fruit. Okay, so this is how actual human vision works. Okay, and similarly computer vision works as well. And in computer vision, the eyes are replaced by a sensing device such as camera, or some video camera, or some a specific type of imaging device like x-ray or MRI scan, etc., etc. Okay, and then these devices are used to capture visual images, videos, and other types of image format. And then these captured images or visuals go to interpreting device, that is basically a computer, and computer gives us an output. So like computer gives us an output that what this specific kind of object is. Okay, so computer vision and human vision are completely same, and in the future lectures you will also see that there's a technique known as deep learning. So deep learning is very similar to human brain. So let me just give you an example of what deep learning is and how it is used in computer vision. Okay, so you can consider this brain to be a deep learning model. Okay, so what this brain is doing, this brain is extracting features from this plate of fruits. So our brain is extracting features. So features can be like what is the color of the fruit, or what is the size of the fruit. So basically, let me just give an example that if our brain is extracting features from So yeah, now I'm audible, right? Sorry, that was some internet problems, I guess. Okay, so I'm audible, right? So where did I left from deep learning model? Okay, so where did I left? Can you just let me in the chat section? It was an internet issue, I guess. Okay, great. Yep. So let me start from the beginning. Okay. So this brain can be replaced with a deep learning model. So when our eye captures an image, eye captures the image of an apple. Okay. So after eye captures this image of an apple, so particular features will be extracted by our brains. Okay, so our brain will focus on features such as what is the shape of the fruit, what is the color of the fruit, what is the size of the fruit, or what is the like or some other specific feature. Okay, so our brain extract these information, and if in case of apple, our brain will extract information that yeah, it's a red color fruit, it's a red color fruit, it has a shape of an apple, or basically it has a texture, it has a smooth texture, and these are the information our brain will extract. Okay, and then using these information, our brain will be easily able to predict that yes, this is an apple. It will be able to detect that yes, this is an apple. In computer vision, this interpreting device is nothing but a deep learning model and object detection model, or a different types of model are available there. So this interpreting device is changed by the deep learning model. So the task of the deep learning model is to basically identify using different features which have been provided by the sensing device that yes, this is a banana. Okay, so let me give you an example of a banana. Okay, so our sensing device, which can be a camera or yeah, so Frederick Lenin D, yeah, it works as a neural network. Yeah, you got it right. So deep learning is all about neural networks, right? Okay, so the sensing images will capture this information, and that information will be image of this banana. Okay, so now after capturing that image, it will give that image to this interpreting device, which is nothing but a neural network or a deep learning model, or different types of model are available there, so there's object detection, etc., etc. So this interpreting device, but every model uses deep learning, its backbone to for computer vision. Okay. So this interpreting device is completely replaced by a deep learning model, or you can say an object detection model, and then it will extract features. Okay, so it will extract that yes, it's yellow in color, it's semicircular type of shape, and it's long. And using these features, it will be able to predict that yes, using these features, we'll be able to predict that yes, this is a banana. Okay, so this is how computer vision actually works. It is very much similar to human vision. The only difference is that devices get changed. Okay, so considering eye and a brain as a device, if we change eye with a sensing device, that can be a camera or any other thing, or brain with a deep learning model and object detection model, so we get a computer vision model. So this is what computer vision is all about. Okay, so here we can see that like human vision versus computer vision. Okay, so this is comparing human vision versus computer vision. As I told you that this is an input, I will see that I will see or and capture the image as well, and after capturing this image, it will give it as an input to our brain. Our brain will basically, our brain has actually seen many different types of dog earlier. Okay, so it will extract the features such as the shape of his nose or ears, etc., and then it will basically try to match with the image of a dog which our brain has seen earlier. Okay, and then it will classify that this is a dog. So this is how neural networks work, and this is how our brain works. Our brain learns from the past and then uses that past information to perform future tasks. So what are, for example, I don't know, for example, take an instance that my brain doesn't know what a fish looks like. Okay, so I will go and just see a fish. Okay, and I will basically understand that yeah, this is what a fish looks like. Okay, and then in future, whenever my brain will get that image of a fish as an input, so my brain will be automatically able to tell that yeah, this is a fish. Okay, and similarly, computer vision, the processing will be done by a deep learning model. And as I told that our brain learns from past information. Okay, so in a similar way, deep learning models or neural networks model that are used in computer vision also learn from past information. Okay, so I will tell my computer vision model or a neural network model that this is an image of a dog, this is an image of a cat, this is an image of a donkey. And whenever in the future, my deep learning model will see that image of a cat, dog, or donkey, it will be able to classify that yes, this is the dog, this is a cat, and this is a donkey. So here are some examples and use cases of computer vision. Okay, so some of the major fields that computer vision covers are object detection, image classification, image segmentation, feature matching, and edge detection, pattern detection, and facial recognition. So the most used techniques of computer vision are object detection, image classification, image segmentation, and facial recognition. Edge detection, feature matching, and pattern detection come at lower ranking points. Okay. So what is an object detection? Okay. So object detection is basically when we provide an image or a video as an input to a computer vision model, which can be any model related to deep learning. Okay, so it will be specifically related to object detection, but so object detection is a technique where we take an image or a video as an input and we try to detect that which type of objects are there in an image or a video. Okay, so this is how object detection works. Okay, So, and in terms of image classification example I've given you, that what a computer vision model or what a computer vision will do here basically is that we will provide this image of a dog to a model, and we will ask the model that is this a dog, or is this a cat, or is this a donkey? So our model will be able to basically predict that yes, or classify basically that this is an image of a dog. So this is an image classification. And on the next image, you can see that this is an example of an object detection. So here we have an input where the cat and dog are present. And when we provided this image as an input to our computer vision model, object detection model, it said that it basically was able to detect that this is a cat and this is a dog. So this is a case of an object detection. Okay. And segmentation basically means that every that the object present in an image will be segmented. That is basically, this is used in automobile industry really well. So in an automobile industry we need to identify different parts of a car. Okay, so if we provide a whole input image to a model, so our model will only say that yes, this is a car. But when we need to identify some specific features of a set, okay, just give me a chance. Slide is not visible. Yeah, I will share the slides. Okay, so it's slides are clear right now. Okay, still not. I'll share the slides, don't worry. Just get the concepts right. And okay. So you all can push up your this what I said. You all can increase the resolution of your images if the sides are not clear. Okay, it's not an issue. Okay, it's clear. Okay, so yeah, what I was telling was that we use image segmentation where we need to specify some specific features in an image. Okay, you will see examples in the when we will be using OpenCV, that how segmentation is done and what are the different types of segmentation as well. Okay, so there are two types of segmentation: instance as well as semantic. So this slide is just a basic introduction of what is image classification, what is object detection, and what is segmentation. Okay, and if you will talk about facial recognition, so facial recognition is used in Snapchat or Instagram. It is used in different security cameras where it detects the face of a person. An industry where computer vision is being used in the industry. So everyone has used Google Lens and Google Translate, right? So Google Lens is capable of pointing and capturing images and then basically showing different images related to that particular object. Or there is also an app known as Google Translate. So Google Translate basically captures the image of the text from real world and then it can be translated into any other language. So everyone is familiar with the Google Translate and Google Lens, Snapchat, Instagram, etc. So these are the perfect example of computer vision being used in the industry. Okay, so in terms of self-driving, okay, so when we talk about developing self-driving vehicles, okay, so the most important task for a self-driving vehicle is to basically know what is going around the car. Okay, so to know this, the self-driving cars are enabled with computer vision. Okay, and this is made possible by using different car cameras and different sensors. So this is one of the best example where the computer vision is being used in the industry right now. And here is like, if I talk about 10 to 15 years back, or just let me talk about 10 years back. So industries were basically hesitating to adopt computer, it and the reason for them was that basically they didn't have much computing power, or computer or deploying computer vision was much expensive at those times. But today every major industry is adapting computer vision. So here are some few points that basically enabled the use of computer vision in industry. So the first point is that we now have access to very high megapixel smartphone camera. Okay, so these are very much capable of capturing high resolution images. So basically, when images are of lower contain much information, okay, and our deep learning model or our computer vision model will not perform better, or you can say it won't give much better results. Okay, so to solve this problem, now we have very high megapixel smartphone cameras. So creating and capturing a high quality or high resolution images or videos is not allowed now. Okay, and the next point is affordable and accessible computing power. So nowadays our mobiles and laptops are getting smaller and smaller, but the computing power is increasing drastically. Like it's increasing exponentially. If I talk about like 15 to 20 years back, or just 10 to 15 years back, we didn't had access to computing power. Like for a normal computer, playing even a moderate game like GTA or so yeah, so basically, my voice wasn't breaking. I was just changing the slides. Okay, I was just changing the slides. So yes, so we have accessible to more computing power, and if yeah, I was talking about that about 10 to 15 years ago, we didn't have much computing power to even play modern games on a normal computers. So now this problem has been solved by ultra low architecture of microprocessors, and now we have more powerful GPUs, and Google has recently came up with TPU, tensor processing units, and these are very powerful computing devices to perform sophisticated tasks. Okay, so the third point is that we have new and more sophisticated algorithms. For example, about 6 to 7 years ago, these deep learning models were very rare in industry and were not being used effectively. And also, since there was limited computing power, so our deep learning models were not being deployed in a scaled way. Okay, so now we have much more complicated algorithms and much more computer vision. Algorithms such as like YOLO. YOLO is one of the most famous object detection algorithm. Okay, so and the fourth point is dedicated hardware for computer vision. Like I told about TPU and GPUs. So these are some dedicated hardware which are used for image and video processing as well. So these are the major points why industries are adapting computer vision at scale. And now let's come to how images are stored in computer. Okay, so if I talk about how images are being stored in computer, okay, so like when we store an image into a computer, okay, so what we see is this photo of Albert Einstein. Like if we are saving this photo of an Albert Einstein, so what we are going to see is that yeah, this is a photo of an Albert Einstein. But what a computer sees and what a computer store is an array, basically array or a matrix of 2 cross 2. So not oh sorry, not 2 cross 2, two-dimensional matrix. Okay, so images are stored in the form of a matrix of numbers in a computer, where these numbers are known as pixels. Okay, so on the right you can see 0, 3, 2, 5, 4, 7. So these are the pixels, and these are the building blocks of an image. Okay, so these pixel value represent the intensity of each pixel. By intensity, I mean that what is the color of that particular pixel. And this value can range from 0 to 255, where 0 represents black and 255 represents white. So we have a black and white image over here. Okay, so the black and white image are two-dimensional images. Okay, and in this image, what basically this image is a black and white. Okay, so the pixels will range something from 0, like it will be near to 0, or near to 0 and near to 255. Okay, so yes, this is what a matrix of this image looks like. So this is a black and white image, so we are getting this two-dimensional matrix. Okay, this is what a computer actually sees. A computer doesn't see that this is an Albert Einstein picture. Instead, a computer sees is a matrix of numbers. So everyone must be aware that computer only knows numbers. Okay, so this is the reason while storing an image, the image is converted into an array, and array or matrix or whatever you like to say. And here different numbers represent pixel values. Pixel value can range from 0 to 255, where 0 represents black and 255 represents white. So these are the basics of images and array. Okay, so let me just tell you about what is 1D array, 2D array, 3D array. Okay, so one dimensional array is just, you can say, a list of numbers. For example, just let me tell that th- just take this as an example. Okay, so these are the numbers 3 and 2. It just contains one row and one column. Okay, no, sorry. This contains one row and two columns basically. Okay. So when we talk about 2D array, so 2D array will look like something like this. Okay. And then 3D array will look something like we have these numbers in front, and then in the back we have another array. Or you can basically understand in such a way that different two-dimensional matrix or two-dimensional arrays, when stacked on one above the other, give us 3D array. Okay, so our image are stored in 2D array if it's black and white, and if it's a colored image, it is stored in 3D array format. And we don't use 1D arrays as much, but yeah, we use 2D array and 3D array for storing black and white images and colored images as well. Okay, so yeah, we have completed this point that images are stored in computer in the form of arrays. Okay, so the black and white images are stored in the form of two-dimensional arrays, and color images are stored in form of three-dimensional array. So that format of two-dimensional array or black and white images is basically X pixel and Y pixel. Okay. So if I tell about that, what is the value of this 0 comma 0 at pixel? Okay. So yeah, this is one. Okay. So this is how the two-dimensional arrays look like, and this is how this is the format. Okay, so a two-dimensional consists of X pixels and Y pixels. So whenever just related to matrix. Okay, just related to two-dimensional matrix. So when we are traversing, so the when we need to access the first pixel, we ask a matrix to give the value at 0th row and 0th column, so it will give 1. Okay, and similarly 0th row and first column, 0th row and third or second column, basically, if we consider this as 0. Okay, and then we come to three-dimensional arrays. So the colored images are stored in the form of three-dimensional arrays. Okay, and basically the three-dimensional array has only three stacked layers. Okay, and that, though, just take this example. Okay, So this is an image of a cat. Okay, so this is a colorful image, and when I will convert this into an array, we will get three-dimensional array. Okay, so now we have two-dimensional array for blue, two-dimensional array for green, and two-dimensional array for red. And when these array will be stacked one above the other, we will say that we have got a three-dimensional matrix of an image. And basically, these three channels represent nothing but different colors. Okay, so one of the most important points to note over here is that every image is consist of only only every image consists of different colors, and every different color is made by mixing red, green, and blue in computer vision. So whenever something tells you that the pixel value of the first pixel is 255, 255, and 255, so that basically means that it's a combination of red, green, blue, and the intensity of the red is 255, intensity of the green is 255, intensity of the blue is 255. When we mix these red, green, blue in this intensity, we get this first pixel. So in computer vision, every color is a mixture of red, green, and blue. So, and in three-dimensional array, or when we have colored image, our pixel form our three-dimensional matrix has format x pixel, y pixel, and 3. So just let me tell you that if I want to get first pixel, okay, so the first pixel in this format, just let me tell you that this first pixel in this format will look something like this: 255, 255. Just a second. So this is the dimension. This is like what our whole image. Okay. So this image will consist of, like, this pixel can be set. This whole image, if the height of the image is 255 and width is 255, so this is the dimension of the image. Okay, so here 3 represents that this is a 3-channel image, and these 3 channels are nothing but these red, green, and blue. Okay, so this is our image. So this is what an image basically, image in vector format, or basically you can say the representation of a image with the, this is height, this is width, and this is the channel of the image. Okay, so if anyone asks me that what is the value of this pixel, okay, just let me change the color. Okay, so what is the value of this pixel? So I will say that the value of this pixel, as evident from here, is that this pixel is comprised of 255, 255, and 255. Okay, so I will say that this image is comprised of red 255, green 255, and blue 255. So these are the value of this first pixel over here. Okay, so this is how our image is represented. When someone asks that what is the resolution or what are the dimension of an image, so this is a dimension of an image. Okay, so these are a dimension of the image, where 255 represents height, 255 represents width, and 3 basically means that this is a colored image, where 3 represents red, that this image consists of red, green, and blue. So Madhu Gandha has this doubt. So for every colored image, number of channels will be always 3. Yep. So for every colored image, the channel will be 3. Okay. And range of RGB values range from 0 to 255. Okay, Arya. So if any color, the range of values doesn't matter which color it is. It will always be vary from 0 to 255. Okay. So if someone asks me that, just a quick test for you all, what will be the pixel value of this pixel? Not visible. This pixel. Just type in the chats, like how this pixel will be represented in this format. You can type in the chat section. I will wait for a minute. And just let me give you that this is the last pixel. So last pixel of the first row. So last pixel of the first row are these three. Yep, great. So the last pixel of the pixel value of great. Yep, it will be 22 comma 22 comma 22. Okay, so don't worry, like this is just an example. Like this image obviously wouldn't contain these types of matrix, but yeah, for an example, basically we can see, or we can say that yes, this, so this will contain 22 comma 22 comma 22. So this is the pixel value of this image. Okay, and what if I want to what would have been the representation of this image, given that the dimensions are same, like this dimension, that is height, and this is width. These two are same, but the image is now in black and white. So what would have been the what would have been the representation of an image in this format? Like whole image can be represented in this format, and the pixels are represented in this format. So you can type in the chat section. Okay, so just let me know that what would have been the representation of an image if the image would have been black and white, given that height and width are still the same. Yes, exactly. Great. Yes, exactly. It would have been 255, 255 and 1. So 1 basically means that the image only contains one channel, and that channel is like black and white channel. You can say as a general black and white channel. Okay. In case of uh, black and white. Okay. So if our image would have been black and white, then the representation of the image would have been this. So everyone got the concept, right? So just let me know if anyone has doubt over here. I can repeat it again. Just let me know in the chat section that if anyone has doubt with these images, or how we are dealing with pixel values, or how we are dealing with black and white images or colored images. Just let me know. Priya has a question. Can we also give that as a 0? No, we can't give that as a 0. That 0 basically means that image doesn't contain any channel, and that can be an issue. Like there wouldn't exist any image which doesn't contain any channel. So images would be either 1, or images would be either this 3 for colored and 1 for black and white. And Soumyadeep Ghosh has a doubt, any colored picture is always have 3 channels. Yep, every colored picture will always contain 3 channels, although there can be different channels as well, but that is left as an exercise for you all. That let me know that if an image can contain a channel greater than 3. Okay, so that is an exercise for you all. And just let me give you a slight hint that we talked about X-rays and MRI scans and that types of images that come from specific imaging devices. Okay, so just check those out and let me know that if an image can have greater than 3 channels. And Harshvardhan Govindraj has doubt that can it be two two channels. Yep, it can be 2 channel, but that would mean that your image is something like a combination of red green or green blue or blue green or blue red. Just apply a permutation combination over here and you will get that thing. Okay. Okay, Avinash has a doubt that in case of black and white images, he has given me an image which is 255, 255, 1 is black and white. The first 255 represent the black color intensity. Then what is that second 255 for? See, Avinash, telling, you are basically dealing with the image representation. Okay, so in terms of an image, this is height and then this is width. Okay, so okay, you have must have been confused about this 255 and this 255. Okay, just let me give you another example over here. Okay, just leave it. Okay, I got your doubt, Avinash, that you are saying. Okay, so this is height of the image and this is the width of the image. Let me change it to something 720 and 720. Okay, so now the image representation will be 720 comma 720 comma 3. Okay, now your doubt has been resolved. That 255 which I wrote over here wasn't this 255, it was the height and the width of the image. Okay, so Avinash got it. This is the pixel representation. Okay, these values are these values and these values are not these values. Okay, okay, Avinash got it. So should I move to the next slide? I will just give you a few seconds and just let me know in the chat section that everyone got the concept right. Okay, great. So these are my work links and I will share the whole PPT with you all, and you can all can just connect me over there and ask me any doubt or any suggestions you all have or any issues with your existing projects or your anything. You can connect me on LinkedIn, GitHub or Kaggle and follow me there as well. And just let me know that if you all have any doubts or something like that. Okay. So now let's just move towards. Let me just share the whole presentation with you all. Just give me a second to clear it all, or it will stay on the screen forever. So I've shared the PPT link with you all. Okay. So you all would be getting that in a minute or something. So I'm moving towards this hands-on with NumPy and different imaging libraries. And today we will be just learning that what different types of how to deal with images, like opening images and saving images, and different types of images, how we're dealing with different types of images, and opening, saving, playing around with them, looking at the dimensions. Let's go on. Okay, so Avinash still has some doubt. Avinash, Pranshu, Anushka have doubt. So Pranshu basically has doubt that what is those two array known in terms of color for black and white images. What is those? Pranshu, can you please elaborate your question a bit more in the chat? I didn't got your question. And Anushka is like, when the number of channel is more than three, what would the image look like? So that's what your today's assignment is. You need to look for images that contain channel greater than three, and just go through them and check what they look like. And Avinash says you can't see that representation because it may contain the UV or infrared channels. Okay, great going. Just check those out. So let me just share the presentation with you all. Okay, here is the. So I've shared the link in the chat section. You all can check it out. Okay. So everyone is familiar with collab, right? We all can use the chat section. So just let me know that everyone is familiar with collab or not. Okay, so Somadeep is not familiar with collab. Okay. So let me just show you how to open a collab for Somadeep. Okay. So you just go to collab.research.google.com and then just go to this new notebook. And the new notebook will be opening over here. Okay. And here we will all perform all the functions and all the work related to. Okay. We will do over here. And this is the Python environment. Okay. So don't get confused. So let me just download an image. Okay. So computer vision image. So I'm just downloading an image. Okay. Stay with me. Or just let me look for dog and cat image. Yep, this looks fine. So you all can save the image and done. So coming back to collab, I will need to upload my image here. And this is my dog and cat image. I will just open it over here. Okay. Okay, so today we'll be using Pillow, NumPy, and Matplotlib. So to use NumPy, just write in. We need to import it first, and just let me zoom in a bit. Okay, so it must be visible to you all right now. Okay. So import NumPy as NP. So this is for NumPy is for array related operations. Matplotlib is for plotting images and graphs in Python, and Pillow library is basically used for opening and visualizing images. Okay, just give me a second. Okay, so we're import numpy as np, import matplotlib for plotting purpose as plt, and importing pillow, importing, so the short form of so this is something we need to take care of, that when we actually import pillow, that pillow is not actually pillow, it's pil. Okay, and when we do this, like when we import numpy as np, so we don't need to write every time numpy. So when we will be using functions, we will just using this np. Okay, so this is why I just created a shortcut. So there is certainly just got a doubt, a CMYK image is a 4 channel. Yep, image can have a greater number of channels. So that's the exercise for the day. Just look it out and let us know in the Discord community. Okay, so to basically read an image, what we will try to do is we will create a variable image, and from pil. Okay, so we are using pillow library to open the image, and a pillow library has this module image which contains open method which is used to open images. Okay, so we need to pass the path of the image over here. Okay, so the path of the image is, you can just go to your left section and just click on this 3 dots and just click on copy path, and then you can paste it over here. Okay, so now the image has been loaded. So to simply visualize the image, we can do this. We can just do img, and we will get to know what our image is. So this is how the Python has displayed your image. It is a dog or cat. And right now we don't know the dimensions or the properties of the image, but pillow is a great library when you need to deal with opening and closing and saving images. Okay, so we have used pillow, and from pillow there's a module image. From image module there is an open method which can be used to open these images, and here you need to specify the path of the image within double colons to open the image, and then you can just print out the variable name image, and the image will be printed. Okay, so let's now convert this image into an array. Okay, so I will create a variable known as image array, and numpy provides us with the uh, fun, uh, function np.array, and we need to specify the image, opened image, which is this. Okay, so here we open the image and stored in this img format, and now we are just providing np.array this image. Okay, so what this will do is this will convert this whole image into an array. Okay, so numpy has converted this whole image into an array, and just let us check how our image array looks like. So this is how the array looks like. It contains 255 to 55 and different types of matrices, and the data type is uint8. So basically it contains integer pixels. So the value of the integers, so the data type stored in this matrix is an integer. Okay, so that's what t type is equal to uint8 tells us. So this is how an image array looks like basically. And now I want to get the dimension of the image. Okay, so I want to now get the image representation. Okay, so what is the height of the image, what is the width of the image, and does it contain, is it a black and white image or a colored image? Okay, so to do that, what we can do, since we have an array, and we can do this image array dot shape to get the image representation. Okay, so you can clearly observe that the dimensions of the image are 630 into 1200, and the number of channels are 3. Okay, So let me just tell you, just let me comment down the notebook. Okay, so there, this is opening an image. This is opening an image, and then this is converting an image into an array, and this is checking the dimensions of an image array. Sujay has a doubt. How did you add the dog and cat image to your file? So you can just download that image, and then on the collab on the left side, just go to this file and then click on this upload, and then just select the image you want to upload and just click on it and just open, and the image will be automatically opened over here. Okay. Okay, so now what we will try to do is we will basically try to, you can say, we will try to rotate the image. Okay, we will try to rotate the image, and to rotate the image we can use different libraries and different uh, you can say different functions as well, which I have pre-built. But since this is a basic session, so what I will do is I will just let you know how to rotate the images directly. Okay, so anyone has doubt till now? Like, we have opened the images and we have printed the dimensions of the image array. So if anyone has any doubt, they can tell me in the chat section. Okay, so no doubts, right? Clear. Okay, so to rotate the images, basically rotating the images. Okay, so to rotate the images, we have a function rotate image, and that is provided by pillow library. And let me just load image again. So from pil dot image dot open. So I will just paste in the path, copying from here. And to rotate the images, just let me, so my image name dot rotate, and here we need to specify that by how much degree I need to rotate my image. Okay, so if I specify 45, then it means that my image will be rotated by 45 degrees. So let me just print the image. So you can clearly see that the image has been rotated by 45 degrees. Okay, and just let me write down the syntax for the rotation of the image. So image dot open image path and dot rotate angle in degrees. So this is a syntax for rotating the image. Okay, so you don't need to just worry about these codes. I will share the notebook with you all. Okay, so that's not an issue over. And just let me now rotate the image again by 90 degree. Okay, so the image has been completely rotated by uh, 90 degrees, I guess. Yep. So the image has been rotated by 90 degrees. So now we can convert this image into converting the images into black and white images. Okay, to black and white. And to do this, we have the same. We have a method from that is below, and that is image dot convert. Okay, so now you can see that the image has been converted to a grayscale image. So you can do this. You can load the image using Pillow library, and then after loading the image, you can use dot convert L to convert the image into a grayscale image. Okay, so you can see that the image has been converted into grayscale, and now the pixels are like they are all either. Okay, so now just let me give you an example of. So let me just show you some interesting thing. Okay, and this is also done using convert. This is going to be something interesting. Okay, so just get active, and I only need some specific colors. Okay, okay, so image is not defined. Okay, oh sorry, I need to provide palette p pil dot image. So this is a palette image. Okay, so to convert an image into a palette image, what we need to do is you need to load the image using Pillow library, and then you can use dot convert, and that under that dot convert you need to provide p means palette, and then you need to define which type of palette. Okay, so I am using adaptive palette over here. You can go on to the Pillow documentation and just check out that what type of other palettes are available. Okay, so just for a quick visualization, what I will try to do is I will try to change the number of colors. Okay, so if I use 20, you will be basically able to see that the more details have been added to this image. Okay, so now the image looks somewhat more realistic than this one. Okay, and now just let me increase the color of the image colors. Okay, okay, so as you go on increasing the colors, you will see that the image is becoming more realistic than the previous one. Okay, so if you want to keep an image somewhat real, looking real, and you want to use palette, you can do this. You can increase the number of colors according to your interest. And to use palette, what you need to do is you need to just load the image using Pillow library, and then using dot convert, you can specify the parameter as p means palette, and then palette is equal to which type of palette, and you can just define adaptive palette. Okay, to define adaptive palette, pil.image.adaptive, you will be able to tell that function that the palette needs to be adaptive, and then colors basically according to your interest, and then you can convert this whole image into an RGB image. Okay, another best thing, like this is one of the most important function we come across daily, and this is resize function. Okay, I will just use image.resize and to resize something like I just want to convert my image into 120 from a 120. So you can decrease the dimension, you can increase the dimension, but if the image is high resolution, I would suggest that you lower the dimension to just get enough computing power. Okay, the higher the dimension of the image, the more computing power you will be able to you will need more computing power to able to process it. Okay, and in case of low resolution images, I won't recommend it to increase the resolution because it will lead to distorted image and pixel flattening or something, like something weird will happen and the image will not look like what it should look like. Okay, and this is the last function for the day. So we can use blur filter. So to use blur filter, we'll be using blur filter and the image will be completely blurred. Okay, okay, so here we are using blurring the image, and to blur the image is a two-step process. First, we need to define the blur filter, like which type of filter we are going to use. Okay, so let me just okay, I don't know what happened to my keyboard, something weird happened. Okay, and I do need to call this blur filter. So this is provided by again pillow. So the blur function takes in the input. So when we need to blur the image, so there are different types of filters available pre-built with the library. Okay, so whenever I need to use the filter for edge detection or some different type of filter, I just need to specify that which type of filter I'm going to use, and here I'm using blur filter. So what this filter does is this filter takes in this image as an input. Okay, and will apply blur filter to blur the image completely. Okay, so you can completely see that after applying blur filter, the image has been completely blurred. Okay, so yep, we'll be sharing the attendance link in the Discord community, so there's not an issue. Why is there two parentheses in the resize function? Okay, so resize function is this. Okay, so dot res I you can't define a single dimension. For example, if height exists, the width also exists. So these are defined in the pairs. Okay, so consider this as like this, that dimensions always must need to be defined under a parenthesis. Okay, now what I'm trying to do is resize takes dimension as an input. So dimension is defined like this, and now image or resize will take this dimension as an input. Okay, so this is why this is the reason why it was under double parenthesis, since dimension are always written in this format, it will be always written under a parenthesis. Okay, so yep, so everyone, that's all for the day. If anyone has any issues, they can connect with me on any platform, and meanwhile you can let me know all the issues or doubts in the chat section. Okay, so we can spend some 5 to 10 minutes clearing your doubts. Yep, I'm waiting. Just and I will be sharing this notebook. Okay, so no issues. I will be sharing this notebook completely with you all, and you all can just play around with all the functions over here. And these were the basics we learned today. Okay, so today we learned what is the basic computer vision, how computer vision relates to human brain, and then what are the different areas and examples where the computer vision is being used extensively, and why computer vision is rapidly being adopted by industry since previous 3 to 4 years. And then we understood that what an image is, what are different channels, and what is the difference between black and white image and color images. How is a pixel value written, how is an image represented in a dimensional format, how to resize the image, how to load the image, how to convert the image into an array, how to view image, how to rotate, and how to apply different filters, how to blur the image, how to convert the image into palette format. So this is what all we all did today. Okay. So tomorrow we'll be covering OpenCV, and OpenCV is a very interesting library. Okay. So using OpenCV, we'll be learning how we are going to perform segmentation, masking, how we crop the images. Like OpenCV is a very well-known library in this field of computer vision. And then we'll be proceeding towards some really interesting functions and stuff over there. Okay, so these are some doubts. We have some doubts. Okay, so let's check them out. Can we change the intensity of the blur? Yeah, you can just play around with this function. You can just play around. There are many parameters. So as of now, since you all are beginners, so I didn't use this parameter. So you can play around with this function and just to gain some quick insights from it. Okay, and can we change a black and white image to colored one? As of now, no. We can change color to black and white, but black and white to color, we don't know that which type. Since when we change an image from color to black and white, all we need to do is we need to basically decrease the number of channels and then tell the function that yeah, this is going to be a black and white image, and then image changes the pixel values. Okay, according to different intensities. And this, when if you want to convert a color in a black and white into color, it's going to be a difficult step, or basically as of now it's going to be a really complicated one, because you need to define intensity of every pixel. So it's going to be a hectic task, although I would say that you must check it out. Like although as of now it's not possible, but still you can check it out and play around with image arrays to clear your concepts. Okay. Okay, so thank you everyone. Bye bye. The notebook and the PPT will be shared over you all. Where can we learn more about these libraries? Tanishka, Yagnesh has the doubt. You can, the best way to learn a library is going through the documentation of the library. So let me just show you how a documentation looks like. So if I want to go to and learn OpenCV, I will just search for OpenCV, and I will go to OpenCV home. Here these things are provided, like they provide courses, they provide resources, but the best way is documentation for Python. So here are OpenCV Python tutorials. So this is an index where you all can just go to a specific link. For example, if you want to perform like if you want to know about what OpenCV is. Okay, so introduction to OpenCV Python tutorials. So here is additional resources, and here is the namespaces, the classes, the different types of files which exist, the modules. So module will give you all the different types of module which are being currently used in these libraries. Okay, so although, and if you want to learn about Pillow, you can just write down this Pillow documentation, and these are the tutorials. So this is a documentation of Pillow. Okay, so you can learn from here. Like here, everything is specified related to library. Okay, so your image.open, format, amp size, amp mode, amp show. So here you can learn everything about a library. And when you gradually increase your ladder day by day in the industry, so you will be also learning this quick thing that one must always go through the documentation of different libraries, because that's the best way to learn the library. Okay, so the best way to learn a library is go through the documentation and learn these things. For example, if you want to learn some machine learning, okay, so one of the most popular libraries is sklearn. So go to sklearn, and then there's tutorial documentation. Go to tutorial. Tutorial will give you different types of codes. Like here's an introduction to machine learning, and you all can just click, and here you will be getting all the details related to library with complete demonstration and explanation of the codes as well. So I would recommend everyone to just, if everyone wants to, if anyone wants to learn a particular library, then one should directly go through documentation of different libraries and just practice it on Colab, Kaggle, Python, or anything you have, Jupyter Notebook. It works well. So, yep. Bye bye.